Okay, estimate the area between the curve and the x-axis, right, from 0 to 1.5. So that's this area right here. Okay, so we're going to find that area. Okay, and then suggest what that represents. Well, let's figure out what it represents first, right? It represents the motion. This is the velocity 0. It gets to a maximum positive velocity, and then it goes back to 0. So we are starting all the way to the left, and we're going to go all the way to the right. And then where we're going the fastest, of course, is right through equilibrium, right? So here our velocity is 0. Here our velocity is 0 again, right? So this is when we're actually at the equilibrium point, is right there. Okay, and so it's basically the distance to go from minus x naught to positive x naught. So it's twice, what is it? It's twice the amplitude is what it is. Okay, now how do you find the area in there? Okay, so let's look at that, right? So we're going to find that area. Basically, each mini square, each one of those tiny little squares, like that guy right there. Okay, one mini square. Remember that the area is the area under velocity graph is displacement, right? So each mini square represents a certain amount of displacement, and all we have to do is figure out how many mini squares there are under that curve, right? In this space here, right? Count all those. Now, don't despair. Like each big square is 25, 5 by 5, so 25, 25. And then this isn't quite 25 because you have to count how many are gone, right? But each mini square is, well, these are milliseconds, right? So each mini square is a tenth of a millisecond. So 0.1 times 10 to the minus third seconds. That's how wide it is, right? That's our width. And our height is, well, let's see. We have to figure that. This is meters per second, right? So this is actually fairly large. 2 is divided into 5 equal parts. So it's 2/5, right? 2/5 is that 0.4 meters per second. Right, notice that seconds times meters per second is going to give you some amount of displacement, right? That'll be whatever, right? And then all you have to do is count out how many mini squares there are. So the number of mini squares times whatever that is that you got, right? Okay, figure that out, okay? And I'll give you a clue. It's between 0.005 and 0.006 or somewhere in that range, okay? Yeah, and then basically what that is that's the displacement of the object from what, minus x naught to positive x naught, so twice the amplitude.